All right, so next thing we gotta cover, and this is the part 3, is isosceles triangles. So remember that isosceles triangles are the triangles that have two sides that are the same in length. So I have two, so AB would be the same length as BC, and they're usually marked by these little lines here that show that those two lines would be congruent or the same length, or as we might say, equal in length as well. All right, so parts of the isosceles triangle. So two congruent sides are called legs. So this and this would be considered the legs. So maybe think of like a tripod, but only two of them. Right, so I guess that kind of makes sense, right? Your legs are both the same size. Well, ideally they'd be the same size. Actually, you know, well, never mind. I'm not going to get off on a side subject. So the next thing is the angle where the legs intersect is called the vertex angle. So in this case here, we have our vertex angle up here at angle B. The side opposite of the vertex is called the base. So down here, AC would be the base, the bottom. So again, kind of like a tripod or something, or anything that's standing up like a chair. Right? I know a chair has 4 legs usually. But something like that would generally have a bottom part where it's kind of held together. You might think of something like, let's see. Well, anyway, base. So just like the bottom part, like the base is usually the bottom part, like a lampshade base or something, a lamp base. In fact, I think most furniture usually has a base, and that's the part that goes in the ground. Anyway, the angles along the base are called base angles. Okay, that's pretty easy, right? Just straightforward, just call them angles. In this case, our base angles would be A and C, or we could also call them angle 1 and angle 2 and angle 3. Actually, angle 1 would be the vertex angle. All right, so those are just the basic parts of the triangle. So what are some other things that we could learn? I'm sorry, like what are the properties? What makes an isosceles triangle isosceles? Well, we have the isosceles triangle theorem, and I know that there's a lot of vocabulary, a lot of theorems and postulates and other stuff like that. And unfortunately, it's just the way geometry is. It's a lot of vocabulary. All right, so if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if we have side AB, so that's here, and that would be congruent to CB, which is over here, then angle C and angle A would be the same. They would also be congruent. So in this case here, angle 2 and angle 3 would be the same degrees in measure. All right, that's pretty easy, kind of an easy thing to do. Because if these two legs are the same, then the opposite angles of that side would also be the same as well. And that's from the base, the part that's not the same. Not this one up here, so it wouldn't be congruent to anything up here. Usually that top angle, the vertex angle, is usually the one that's different. All right, so converse of the isosceles triangle theorem. So isosceles triangle theorem again, but it's converse. So it's like the same thing, but kind of opposite or backwards. So if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So like if A equals C, so if we know that this, you know, is a certain degree measure, and that's also the same degrees. So if the angle degrees are the same, then the opposite side, so again, it's backwards, whereas the other one was saying, well, if the sides are the same, then the angles are the same. This one says if we know the angles are the same, then the sides are the same. So again, it's the same thing, just backwards, just kind of the backwards logic of it. All right, so I'm gonna go ahead and go down. Hopefully that covers everything we need to know about these triangles. So find each measure. All right, so measure of angle J. Measure of angle J. That would be 68 degrees, because again, these two would be the same. If we know these two sides are congruent, the angle at their base must also be congruent. All right, so if we know that that is 68 degrees, well, how would we find angle K, or the vertex angle? Okay, so if we know that this is 68, well, we'd have to add those two numbers. So 68 plus 68 equals 180. And in this case, we're missing one of them, and I'm going to call that K. So I'm going to go ahead and get my calculator. I'm going to add those two 68s together. I could have just pushed times 2. And if I put those two 68 numbers together, combine my like terms, that would be 136. And then I'd have to minus 136 from both sides, and that would give me 44. So there we go. That's how we got the measure of angle K is 44 degrees, because remember, all interior angles must add up to 180 degrees. All right, so let's go ahead and move on to the next one, number 2. So we know we have an obtuse angle. That's a pretty big angle. You can see that it's pretty big, but it also tells you that it's 106 degrees. Okay, so how do we get these other two sides? Well, we know that if this, tells us that this angle would be the same, and this tells us that that angle would be the same. So these two angles would be the same size. So if those two angles are the same size, well, then it would just have to be the difference of those two angles. So I have, in this case, since they're the same, I'm going to go ahead and oh gosh, what can I call them? Because really it would be something like this: 106 plus angle C plus angle E. Okay. But in this case, since we know they're the same, I'm going to call them both angle C. Okay, they're just because they're the same thing. Like if this, well, in this case, we know it's 37 degrees. So if that one's 37 degrees, then this one would also be the exact same amount. So combine our like terms in this case. So we have, okay, so I'm going to switch sides. So I'm going to put the C first just because that's a little bit easier to do. And now I'm going to do 180, and I'm going to minus 106 from both sides, and that would be 74. So, oops, 2C equals 74. Now I have 74 degrees to split between these two angles, angle C and angle E, which again, they're the same angle, which is why I just went ahead and just used one variable for that. And if I divide both of them, 74 divided by 2, well, again, I already know what it is. We already know, we can see it. But that's how they got those set of 37 degrees. Oh, excuse me. All right, so let's go ahead and get to the next one here. So YZ, so side YZ is what they're asking for first. Well, the definition of an isosceles triangle. Now, sometimes we might have to, we may not know it's an isosceles triangle. All right, so this chapter is kind of easy. I mean, just looking at this, you can say, okay, well, this is likely going to be an isosceles triangle because that's what the lesson is called. It's called isosceles triangles. But let's say you're finding this problem somewhere that's not in a chapter, like way down the line, right? Or maybe it's a test, and the test doesn't say this is an isosceles triangle. Well, how would you know that? If this is 77 degrees and this is 77 degrees, then that means this one would also be 12 degrees. I'm sorry, 12 centimeters. Getting carried away with all the degrees. So that's how we know that YZ is 12 centimeters. And lastly, they want us to find the measure of angle Y, which this would be pretty easy, because 77 plus 77 would be 154. And I just have to see how much is left over from 180. So 154 subtract from 180 would be 26 degrees, which they have right here. So not bad. We got it. All right, so in this case here, it looks like they're going to throw in some algebraic expressions. So algebraic expressions have variables and numbers. All right, so how would we find the value of each variable in this case? Well, we know because, again, isosceles triangle theorem says that, Yeah, that is what it's called. I just had to, I don't know why I second guessed myself. Anyway, that means this side would mean that this angle here, so we have two identical sides, legs, and that the across them, right, the base angles would be the same also. So if we know the base angles are the same, what we're going to do is we're going to set them equal to each other. 5x plus 9 equals 8x minus 30. Do our algebra stuff. So, well, first off, we don't have any like terms or parentheses, so that's, you don't need anything from that. Move on to step number 2, which is to move the x or the variable to one side. So in this case, we are dealing with x. So I'm going to minus 5x from both sides. 8 minus 5 would be 3, so that's where we get 3x here. And then I'm going to have to add 30 to both sides. So if I add 30, it'll cancel it from this side. And I get 30 plus 9, which is where we get 39 from. Divide both sides by 3, and, well, we get 13. So we know x is equal to 13. And that's pretty much it. It's not asking for the degrees. So we're done with this one here. So, but be careful, read the questions, right? So always read the questions, because sometimes there will be questions that will not match up. That will be questions that will, sometimes I'll trick you, okay? Like in this case, the directions say to find the variable, but sometimes it'll say something like find the degree of all interior angles or something like that, which in that case, you'd have to provide that instead. So make sure you read the question and make sure you answer the question is always good advice. All right, so same thing with this one here. So we have another isosceles triangle, and in an isosceles triangle, the odd side is always considered to be the base, okay? So I know generally when we think of the word base, we think of something that's on the bottom, but like in this case over here, the base is actually on the top of the figure. And here it's kind of pointing to the left, and actually on this side, on this triangle here on number 7, the base is on the top. So even though they call it base, it doesn't always mean the bottom, okay? It's just like if you were to stand a piece of furniture upside down, you could do it, but it's not on the base, okay? The base is supposed to be the bottom, but that doesn't always mean it is the bottom. Anyway, let's get back to here. So 4x plus 7 and 9x minus 33. And again, if we use the isosceles triangle theorem, we know that these two angles would be the same or congruent. So we're going to go ahead and set them equal to each other. 4x plus 7 equals 9x minus 33. Okay, minus 4x from both sides, because I want to move my variable over to the other side. That way I know it will be positive, right? I like to keep my variables positive, and it's always a good thing, again, just because you can look at your work and kind of tell, well, hold on a minute, that's not right. Especially in geometry, you rarely deal with negative numbers in geometry, because geometry is always measuring something, and in measurements, you can't have a negative degree, or you can't have negative degree, you can't have negative length. I mean, there might be some like special cases, but for the most part, no. Anyway, let's go ahead and add 33 to both sides. So 33 plus 7 will be 40. Now I need a number to multiply by 5 to get 40, and that would be 8. Now I'd like to reverse this really quick. You know, to me, I would prefer it like that. Okay, just going to use our symmetrical property on this one here, and just switch sides. This is the way I would prefer it, actually, because again, you don't say, like if somebody is 8 years old, they don't say 8 am I, they say I am 8 years old. You know, something like that. That's the way we would say something, especially in English. You know, like the marker is blue. We don't say blue is the marker. It's a small thing. I don't think I'd really mark anybody down points for that, but that is generally the better way to write it. Okay, so in this case here, it looks like we're looking at the lengths. We're using the converse isosceles triangle theorem, because we know that if these angles match, that means their opposite sides would also match. So in this case here, they do the same thing. 15x plus 7 and 23x minus 17. So that's where we get these numbers from. 23 minus 15. Well, okay, that'd be 8. So we have 8 left over here. Add 17 to both sides. So plus 17 to 7, and we get 24. And what number times 8 gives me 24? Okay, that one would be a pretty easy one. We would know that it would be 3. 3 times 8 is how you get 24. But again, I'm going to use the symmetric property, and I am going to flip that side. Wait, 8? Sorry, I was saying, I sometimes when I'm saying something and I'm writing it, I think I have a tendency to write what I'm saying and not the other way around. There you go. Yeah, we don't usually talk backwards in stuff. Like if I said, I don't really have anything nearby that I could pick up. But we wouldn't, you know, if someone wouldn't say something like, I have, I don't know, 3 pencils. You know, I have 3 pencils. You don't say 3 pencils I have because, well, you're not Yoda. Anyway, let's go ahead and move over here to the last one. Now in this case here, we know this is 74 degrees. This is 74 degrees. So since we know that both of these bases, and again, base just means, you know, the side that's not congruent, doesn't really necessarily mean the bottom. Well, we know that these opposite angles would also be the same. So therefore we know this is an isosceles triangle. And like I said, sometimes you have to kind of know it's an isosceles triangle before you start using isosceles triangle theorems on it. So in this case, we know it's an isosceles because there's 2 base angles that are the same measure, in this case, 74 degrees. So there we go. Now we know that they're the same side, right? Because this side would be congruent with that side. So we just set them equal to each other, carry out our algebra. So 3x, because I'm going to move it over to the left. So I'm going to minus 3x from both sides, and that would be 6x. And it looks like I'm going to have to add 73 to both sides. So 23 plus 73 would be 96. And in this case, I probably would need a calculator and just to keep things going along a little bit quicker. And we get 16, which is exactly what we have there. And I got to be careful because sometimes we do get weird answers. Sometimes we will get something that is different than what we might think, okay? I know sometimes like, it's already happened on one of these already. If you remember last week, there was one that was wrong. So sometimes I do check them. Anyway, so we're done with this page. I'm gonna go ahead and get ready to go to the next page. Okay, just in case anyone's needs to finish this up a little bit more. All right, so. All right, I'm gonna go ahead and move on to the next page. I'm gonna clear up some of this and then we're gonna get going. And we have this one, and then that's pretty much it. This is a pretty short chapter in this case. Short, nice chapter. So I'll give you a minute or two. Let me go ahead and start that timer. Probably 3 minutes. I'll go with 2.5. Sometimes I really do have to kind of think about how long this will take to write down. Okay, so I'm gonna go ahead and take attendance again while we're waiting, just so that way I can have it up to date. So hopefully everyone who's here is the people that need to be here. All right, I'm only missing one person today, which is weird because that's one of the people that are usually here. Didn't quite make it to either session. All right, so I'm gonna move it down just a little bit, and because if you're done with those first two, Well, maybe I'll just cover up that first one. I'll move it down a little bit so that way at least you can see the second one. Number 9 in this case. And still got 2 more, oh, well, let's see, about 1 more minute left. And I think there's only 1 or 2 more at the bottom. And if you missed any of the ones like on number 8 and 9, don't worry about it. We're going to go back up there just in a minute or so. And if you didn't get these ones, again, we're going to go over them all together. This is just a chance to kind of catch up so you're not writing everything down, you know, as I'm talking about it or covering it. So not that we're really in a hurry though. We still got like 20 more minutes and this is only a 2-page kind of short exercise. Short lesson, I should say. And like I said, don't worry. We're just going to continue this week as normal. I know there were some kind of weird things about the schedule. All right, the schedule was kind of a, I don't know exactly how it's supposed to work, but I'm going to keep going just as normal until I'm told not to. Because I've heard different things from different people and I don't know. All right, I'm gonna go ahead and give it about 30 more seconds and then we'll go back to the top and then start it over again. All right, so going back to the top now. So let's see, in triangle RST, so you're gonna have to draw that yourself. It says RT is congruent to ST. So when you label it, make sure you have those two as your legs, as the base legs. Well, not the base legs, just legs. Okay, those are the 2 sides that would be the same. Measure of angle R, so starting from R, that would be 9x plus 2, which normally they would put it here. And angle S, so the next statement they say is angle S is 13x minus 18 degrees. And we already know that those 2 are going to be the same. So we know if these 2 sides are congruent, the 2 base angles should be congruent as well. So being congruent means we can go ahead and set them equal to each other. And let's see, minus 9x from both sides, 13 minus 9 would be 4x. And then 18, so I'm gonna have to add 18 to both sides. So 18 plus 2 would be 20. So 4x, so 4 times what gives me 20? Well, that'd be 5. Now again, make sure you read the questions because in this case it says find x and the measure of each angle. So we still have 5, so don't just end it right there. Well, this one would actually be kind of a hard one to miss because it also gives you, you know, places to put the other answers for angle R, angle S, and angle T. So what we're going to have to do for this one here is we are going to have to plug them back in. So just like some of the other exercises we've done, now that we know X, let's plug them in. So the first one it's going to ask for is angle R. So go back to R, let's plug it in. So that would be 9x plus 2, but take out the x, right? And we're going to put in 5. So 9 times 5 would be 45 plus 2. And that's how we get 47. And then to get the next one here, angle S. So now we could probably also, since we know this is an isosceles triangle, that the angles would be the same as the sides, right? So angles are the same, sides are the same. So we could probably just say this is also 47 degrees. Now we could double check it just in case we made a mistake on this one. Double check the other one by plugging it into here. But in this case, I'm pretty sure that's the right answer. So anyway, 86. So how do we know this last side is T? Because in the statement, well, actually it says it right there. So reading the statement again, we do have a measure for angle T. So that'd be 17 times 5 plus 1. And I actually am not sure what 17 times 5 is. So that would be 85 plus 1. That would be 86. And that's how they got that one. And again, you can fill this middle one, angle S, using that statement. So there's usually a couple of different ways you can do this. All right, so anyway, let's go ahead and move on to the next one. So we have another triangle, DEF. Now, before we could probably draw the triangle, but be careful because some of these we do need to have them known. Like in this case, angle D and angle E are the same. Okay, angle D and E are the same. So that means the two bottom angles or the base angles would be D and E. Okay, so when you're labeling it, don't put F here as either of these bottom ones. Those would have to be D and E. So anyway, side D, E, so that's the bottom actually. This is the bottom, X plus 4. Angle EF is 4X minus 8. And DF is 7X minus 35. So sometimes it's a good idea to fill out the whole thing. You don't really need to, but I would suggest it because it does help keep everything in order and in a nice orderly manner. All right, so now that we have it all labeled, and having it labeled makes it easy to spot which ones are the congruent sides. So, you know, don't put X plus 4 in your equation. Don't set them because it's not equal to either of these things. Right, the ones we need that are equal would be 7X minus 35, which we put right here, and 4X minus 8, which we put on the other side. Carry out our algebra. So in this case here, minus 4 from both sides. So 7 minus 4 would be 3. Add 35 to both sides. So that'd be like 35 minus 8, which would be 27. And X equals 9. And I don't really see a whole lot of decimals or fractions. I mean, like if you're dealing with slopes, you'll probably see some fractions. But for most measurements, actually, I've noticed that there's not a lot of them. And I was grading some of the homework not too long ago. And I noticed that there were some people putting decimals in the homework when there doesn't need to be, right? So so far, like when you're dealing with measurements, like with sides or angles, usually it's not going to be a decimal. You're not going to have like say 9.5. So if you do run into a decimal, make sure you double check it. Because again, I've been seeing a lot of them in the assignments. All right, so plug these back in. So angle DE, which is down here. So D, so it'd be X plus 9, but we also know that X is now going to be equal to, oh, well, hold on a minute. Oh, it's supposed to be X plus 4, and then replace, well, you'd still get the same thing. So that bottom side would be 13. And we'd have to do the same thing with one of these here. So plug in, I guess, DE. Oh, we already did DE. So we probably need EF. So that'd be 4X minus 8. So that'd be 4 times 9, which would be 36 minus 8. And that'd be 28. So now that's where we get this one from. And I guess since I didn't do this the last time, I'm going to go ahead and do it the way just like this time here. So 7 times 9 would be 63 minus 35. So that would still be 28. And in this case here, I went ahead and just wrote them all out, but I kind of didn't do any of the work because if I did, I wouldn't be able to fit all of them in there. Okay, so I guess we're done with that one. And again, these are just kind of showing you how they're done. Unfortunately, if I move down, I'm not able to keep it. So here's what I mean. If I scroll down, you see now it's not lined up anymore. So I'm gonna have to move on from there. Sorry. All right, let's do another one of those. So we have a triangle WXY. So WX is the same as WY. So we know these two sides are congruent. So those would be the legs. Let's see, angle W is X plus 6. And I'm gonna go ahead and fill this in again. So angle W is X plus 6. And since I don't have enough room in there, I'm gonna put it off to the side like here, X plus 6. And angle X is 5X minus 12, 5X minus 12, and then put it right there. And Y is 7X minus 48, 7X minus 48. Find X and the measure of each angle. So again, this helps us find out which one it is, right? Because I can see these are my two base angles, 5X minus 12 and 7X minus 48. That's the hard part, I think, is just setting them up. So the algebra and the math is not so hard, but setting them up is the hard part, because now you have to look at which one would be the same, right? Because if you put X plus 6 in either of these, you probably would not get the right answer. In fact, I'm pretty sure you wouldn't, because the whole idea of the theorem is that these two are the matching sides, or in this case, matching angles. So let's see. Looks like we're going to minus 5X from both sides so that we move X over to the right of the equation. So we get 2X. And then add 48 to both sides, which if we add 48, it'd be like 48 minus 12. And that's how we get 36. So 2 times what gives me 36? Well, that'd be 18. So I'm going to put 18 in there as X. And I'm probably not going to go through all of these again to just like plug 18 into each of these, but hopefully you get the idea, because that's what you would do. Plug 18 into each one of those 3 equations to get these ones here. So you, again, plug them in, evaluate them, get them. All right, so moving on, we only have about 10 more minutes. So I thought this would be kind of a shorter one. I guess I was not right about that. Oh, I'm already at the bottom, so I don't need to go any lower. And it looks like here we have equilateral triangles, and kind of looks like they just sort of threw this one in there because there's only like 3 examples and a very short thing of what to know about equilateral triangles. But equilateral triangles are also the simplest ones because, well, equilateral means, well, if you look at the word equal, it means equal, right? Right there, it just says equal. Although it's spelled a little bit different, spelled with an I instead of an A. And lateral means side, so equal side triangles. Okay, so if we know one side, we know all 3 sides. So a triangle is equilateral if and only if it is equal angular as well. So that was one of the other things we talked about recently. I think it was like Friday or so. No, Friday, we didn't have school Friday. We had Thursday, there you go, Thursday. So one of the days is Thursdays, and one of the things we talked about is equiangular and equilateral are the same thing. Because there's no way you could have a big angle, because if you had a big angle, one of these sides would have, like if I had C and it was a bigger angle, well then this AB would have to be longer in order to compensate for it, which in that case, it is no longer equilateral or equiangular. So in other words, all 3 sides must be the same. AB equals BC, and that equals AC, or in this case, they call it a CA. And all 3 angles must be the same. Angle angle B and angle C are all equal to each other. So again, not very difficult. They all have to have the same angle. And in fact, there's usually only one set of angles that they could be. So let's go ahead and look at this one here. So if we know that this is 9 feet, well, first off, again, don't trust the diagrams sometimes, all right? So in this case here, we're talking about equiangular and equilateral triangle. So this is probably one of those. But let's say again that you're on a test, or it's been a long time, but you're seeing this triangle here. Well, you would know that this is 60, that's 60. What would this one be? Well, it has to equal 180, so that would mean that this would also have to be 60 as well. Now, if they are all equal angular, that must mean that it is equilateral, so that the length of the sides is also 9 feet. And that third side was 60 degrees. Now, in this case here, it's the only questions it's asking is angle J, angle K, and angle L. They're only asking about the angles. Well, again, before we just say 60, don't trust the diagram, because sometimes, you know, questions are kind of mean like that, and the diagram doesn't actually match what you're seeing. So we'll have to verify this first. So it has these 3 marks, and that says that all 3 sides are congruent. And if all 3 sides are congruent, well, there's only one combination of interior angles that will work, and that is 60, 60, 60. So all 3 angles would be 60. So that's the only one that will work, and it doesn't give us any one of them, because we should know that they're all 60 degree. And that's what they did with this one here. If we look at this next example, PQR is an equilateral triangle. Solve for X and Y. So here we have one of them. This is pointing to an angle, and we can kind of look at some of these. Well, actually in this case, there's Y, Y, Y. So all the sides have Y. Well, again, if it's equilateral, that must mean that each side is 60 degrees. So it doesn't say 60 degrees anywhere on this picture. It doesn't say 60 degrees. What it does, what we have to do is we have to know that it would be 60 degrees. So that's what we're going to do. That's why we put the 60 here. So set that 7x minus 3 equal to 60. And that should give us the value we need for x to make this equal 60. So add 3 to both sides. So we get 63, 7x equals 63, and that would be 9. So 9 times 7 is 63. All right, so that was x. And we can check it by plugging it in. Don't forget, you can always plug these in. So if we have 7 times x, which is 7 times 9, that would be 63 minus 3, and that would be 60 degrees. So we know it works out. And don't forget, you can always check things by plugging them back in. Let's go ahead and move over to the next one here. So in this case here, we have all 3 sides with Y. So Y here, Y there, and Y here. Now, since we know that this is all equal angular, I can pick any 2 sides, and work it out. Now, I would pick this one definitely, because it's got the smallest numbers in it, 9y plus 1. And I would not pick this one here, even though they did pick it here. I would go with this one just because the smaller numbers might make it easier to calculate. But, you know, let's just follow what they did here. So they got that kind of complicated side and put it here, which is, it's not that bad. It's not like it's way more difficult or anything. They just minus 9 from both sides, right? You get 5y. Add 59 to both sides. So 59 plus 1 is 60. And now we have 5y equals 60. So what 5 times what gives me 60? Okay, that's easy. Easy enough. It's just 12, right? So y has to be equal to 12. And I could check it by plugging it into each of these, and I should get all 3 of these to be the same degrees in measure. I'm sorry, wait, not degrees in this case. We're not talking about angles. Well, it doesn't tell us if it's in inches or meters or millimeters or anything like that. So we don't know what this unit is, which in this case, if you know what the unit is, like in this case here, go ahead and write those units. Like in this case, we got centimeter. Over here, we got feet. So if you know what they are, go ahead and put them in there. If you don't know what they are, go ahead and just leave them out, because it probably, I mean, I don't want to say it wasn't important, but you know, if they wanted you to put it in units, they would have given you the units, is basically what I'm trying to get at. So if you have units, put them in there. That's all you have to remember for this one. And that is it for today, for this second lesson of the day. So I'm gonna go ahead and let you guys get to your second hour. We're done with what we need to be doing with today. So I'm gonna go ahead and close this out and give my second hour some time to show up. I think I already took the screenshot for attendance, so that should be taken care of. So if you're here, make sure you're here on time, because the screenshot happens at a certain time, and I don't want to tell people what time it happens at, because if I tell people, well, it happens after this number of minutes, then they're going to wait for that number of minutes to show up. So please just show up at the beginning of class, and that's the best way that you won't be marked absent. Okay, because I don't think I'm going to drop anybody unless you're missing a lot of them, because we're already on the last week, and it wouldn't make sense to drop somebody with only a few days left. So anyway, please get here on time. Please make sure you stay through the entire lesson, including the independent student learning time period. All right, so that's it. I will see you guys again tomorrow.